All right, here's a video going over the trigonometry and rational exponents exam. I'll make this quick. If you feel like the pace is too fast, you can always adjust the playback speed in your YouTube app to slow it down a little bit. Any other questions, please feel free to ask me. All right, number one is to convert x to the 3/4 into radical form. Now what we need to remember is that when we're doing these, the top is a power and the bottom is a root, okay? So what that means is this is equal to x underneath a 4th root with a 3rd on top, or you could put it as x cubed underneath a 4th root. They're both the same thing. Okay, same idea here. Remember that this is the root, this is the power, and a negative means 1 over. Okay, so I'm going to do them in that order. It's not necessary to do them in that order, but that's the way I like to do it. So 2y underneath a 5th root with a square on top, all under a 1. I'll convert this into exponential form, so we're going in the opposite direction here. So this right here is the denominator, and this right here is going to be the numerator. So this is equal to x to the 7 over 5 power. 8 to the 2/3, okay? We're going to convert it first. 8 underneath the cube root, the square on top. Now, the cube root of 8 is 2. So this is equal to 2 squared, which is 4. Number 5, we want to evaluate this. This is equal to 1 over, because of the negative, 1 over 4 squared, and that means it's 1 over 16. The equation of a sine function that has a midline of -2, a maximum value of 4, and a period of 6. So let's do this real quick. I like to draw a little diagram. Has a midline of -2, has a maximum value of 4. So let's think. And the period is 6. So that means it looks basically like this. Let's think. To go up here, right, this right here, up here, this is +6. Now that's the amplitude. The amplitude is how far up and down we go. The midline was given to us. Midline is -2. And the period is 6. But let's remember what this looks like. This is y equals a sine of fx plus the midline. So I have the amplitude. I have the midline. I need the frequency. Frequency is equal to 2 pi over period, which in this case, period is 6. So this is 2 pi over 6, which can be simplified 2 over 6 into 1/3. So this will just become pi over 3. So when I write out the function, I'm going to get y is equal to 6 sine of pi over 3 x plus the midline, which is -2. All right. Equation of a cosine function. So y equals a cos of fx plus the midline. Let's draw a little diagram so that we can figure out what goes where. It has a maximum value of 10 and a minimum of 4. So let's figure out 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So I think 1, 2, 3, this would be the middle, right? So this is 7. You could also choose, oh, I didn't realize the eraser was that big. You could also choose to take the min and the max and average them. 10 plus 4 divided by 2. That's still going to be 7. I know that I'm correct because check this out. Going up is +3. Going down is -3. All right, so that's my amplitude. I know that my midline is 7. And the only thing I need is the frequency. Well, it says the period is 2 pi. So frequency is equal to 2 pi over period, which is 4 pi. The pi's cross out. 2 over 4 is equal to 1/2. So my final answer is going to be y equals, amplitude is 3, cos of 1/2 x plus 7. Draw a graph of this function. So we need to make sure that we show all 3 of these attributes, right? So here's how I choose to do it. This right here is frequency. Period is equal to 2 pi over frequency, which in this case is 2 pi over 3. And that's period. All right. That makes my life really easy because when I go to graph it, I'm just going to put that number on the end of the number line. 2 pi over 3. And that way I only have to draw one graph because period by definition is how long does it take for one cycle. So now the good thing is I know that my sine is going to look like this and it's going to end right at 2 pi over 3. Otherwise I would have to draw 3 of these, 1, 2, 3, and that's a little messier. I'd rather do this. All right, now 7 is the midline. 4 is the amplitude, so it's plus 4 minus 4. This is 11, and this is 3. And this is a perfectly 100% graph. All right, moving on. 9, an oceanographer is measuring tidal patterns in Zack's Bay. He starts measuring at low tide, 14 inches deep, and finds that the maximum height is 30 inches deep. So let me start with the diagram. Maximum height, minimum height, 14 and 30. If I add those together, I get 44. I think that means my middle is 22. Let's see if that's right. This is plus 8. Yep, that makes sense. And this is minus 8. Yep. The tidal cycle takes 12 hours, so that means 12 goes right here. He said it starts at the minimum, so I think the graph looks like this. And what that is it's a negative cosine function. All right, so here's my graph. Graph is done. And here's the function. Y equals a cos of fx plus the midline. I know the amplitude is plus 8, right? So it's 8. I got to remember that it's negative because of the shape of the cosine function. The frequency, I still have to find that. The frequency is equal to 2 pi over period, which is 2 pi over 12, which is pi over 6. So I got that now, and the midline is 22. So my formula is y equals negative 8 cosine of pi over 6 x plus 22. And both parts of this, the graph and the function, give us full credit here. Use the space below to write everything you know about the trig functions and cofunctions. Let's see. I know cos and sine. I know that tan is equal to sine over cos. I know that secant is equal to 1 over cosine. I know that cosecant is equal to 1 over sine. And I know that cotan is equal to, what's the flip of this? So let's see. That means it must be cos over sine. Okay? That's everything I think I need to know. Let's move on. What is the original Pythagorean identity? That is cosine squared theta plus sine squared theta equals 1. Or vice versa, you could switch these two. The order doesn't matter. Show work to solve for the second and third Pythagorean identities. Okay, so in both cases I'm going to have to start off with the original, so I'm going to make a couple copies of that, save myself the time of writing it. Here's how we find them. We divide everything by cosine squared. And on the second one, we're going to divide everything by sine squared. Now all I have to do is simplify. Cosine squared over cosine squared is 1. Sine over cos is tan, so this must be tan squared. And 1 over cos is, I wrote it on the other page, that's secant. So this is secant squared theta. Cos over sine, we just wrote that down. That's cotangent, so it's cotangent squared. Sine squared over sine squared is 1. And 1 over sine squared is cosecant squared theta. Now I'll do the two proofs, but I'll do them quick. Prove that this is an identity. So we have on one side tan squared theta, sine squared theta. And on the other side we have tan squared theta minus sine squared theta. Okay, this is my left-hand side, and this is my right-hand side. Now let's do some manipulation. Let's turn everything into sines and cosines. Tangent squared becomes sine squared over cos squared. Sine squared becomes 1 over, oh no, wait, vice versa. Sine over 1, so sine squared theta over 1. If I multiply these, top times top is going to get me sine to the 4th theta, that's weird, over cos squared theta. I don't think there's anything else to do on that side, so let's look at the right-hand side. I'm going to turn tan squared into, like I said before, sine squared over cos squared minus sine squared theta over 1. I can't subtract fractions unless they have the same denominator, so what I'm going to do is this. I'm going to multiply by cosine squared theta on both the top and the bottom. Now that they have the same denominator, I can smush it together. So I'm going to get sine squared theta minus this, sine squared theta, cos squared theta, all over cos squared theta. The top has a GCF, I see that. Maybe I can pull a sine squared out to the front. So sine squared theta, parentheses, 1 minus cosine squared theta, all over cosine squared theta. And this right here looks like an identity. So let me go to the identities. 1 minus cosine squared. Let's see if I can come up with that somewhere. 1 minus cosine squared. So if I minus cosine squared, let me change my color. If I minus cosine squared on this side and minus cosine squared on this side, this will cancel out. And I'm going to get that 1 minus cos squared equals sine squared. Perfect. 1 minus cos squared equals sine squared. So that means this right here can become sine squared theta. So I get sine squared theta times sine squared theta over cos squared theta, and that is sine to the 4th theta over cos squared theta, which, if you look at the left and the right-hand side, they are now equal. So the left-hand side equals the right-hand side, which was what we wanted. Okay, I'll do the second proof. If you had the other version of the test, just so you get a little example of what happens. I'm using the same information, the same identities, so I'm not going to fill out 10 and 11. I'll just prove the identity here. So I have cosecant squared theta, tan squared theta minus 1, and I want to prove that that's equal to tan squared theta. Well, it doesn't look like anything's going to happen really on the right. That's pretty simple so far. So let me just handle the left. Cosecant is 1 over sine squared theta. Tangent squared theta is sine squared theta over cos squared theta minus 1. The sine squareds are going to cancel out. So I get 1 over cosine squared theta minus 1. Now this is 1 over 1. I can't add these or subtract these unless they have like denominators, so same move as before. Multiply by cos squared theta on both the top and the bottom. I can smush these together, 1 minus cos squared over cos squared. The same exact identity I did a minute ago, 1 minus cos squared is sine squared theta. So I get sine squared theta over cos squared theta, which is the definition of tan squared theta. And now if we look, our left-hand side is equal to our right-hand side, which was what we wanted. Quod erat demonstratum. Okay, so that's your review on that. If you need any additional help, please see me in office hours.